Ever wonder how that perfect loaf of bread lands on your table? It's not magic, though it sometimes feels like it. It's science, it's engineering, it's industry. We're talking about bread factories, folks. Vast operations churning out millions of loaves daily. Yes, you heard that right, millions. It's a symphony of steel, flour, and fire. A modern marvel hidden in plain sight. These factories are the unsung heroes of our breakfast tables. They ensure that a staple food is always available and affordable. Think about the sheer scale. From tiny yeast cells to towering ovens, every step is precisely controlled, meticulously planned. This isn't your grandma's kitchen, though her love for good bread is there. It's just amplified 1,000-fold. Let's peek behind the curtain, shall we? The journey of a loaf of bread is quite something. It starts with humble ingredients but ends up as a cornerstone of meals across the nation. These factories are more than just buildings with machines. They are powerhouses of production, models of efficiency. They feed millions day in and day out. It's a responsibility they don't take lightly. And the process? Oh, it's fascinating. Prepare to be amazed by the journey of bread. So, buckle up, bread enthusiasts and curious minds. We're about to embark on an incredible journey through the heart of a colossal bread factory. We'll explore every nook, every cranny, every step, from raw materials to the perfectly packaged product. You'll see how technology and tradition intertwine to create something we often take for granted. First things first, ingredients: flour, water, yeast, salt, the Fab Four. But in a factory, we're not talking cups or pounds. We're talking tons, literal tons, daily. Huge silos, gleaming metal giants store the flour, delivered by special tanker trucks, not little bags. This flour is carefully selected, tested for quality, protein content, moisture levels, everything matters. Consistency is the name of the game here. Water, seems simple, right? H2O. But even water is treated and precisely measured. Its temperature is critical for yeast activity. Factories have complex water treatment systems, ensuring purity and the perfect temperature every single time. Then there's yeast, the living engine of bread. It arrives in refrigerated trucks, often in bulk containers. Salt. It's not just for flavor. Salt controls yeast fermentation, strengthens gluten. It's a workhorse in the dough. Like flour, it's bought in massive quantities, stored carefully to prevent clumping. And what about other ingredients? Seeds, grains, sweeteners. Think molasses, honey, or perhaps vital wheat gluten. Each one has its own storage needs, its own supply chain, all managed with an almost military precision. Managing this colossal pantry is a logistical feat. Computers track inventory levels constantly. Ordering is often automated, ensuring no shortages. First in, first out systems guarantee freshness. Quality control checks happen at every stage. From the moment a truck arrives, samples are taken, tested in labs before anything is unloaded. Because great bread starts with great and greatly managed ingredients. Once the ingredients are gathered, it's time for the big mix. This isn't about a bowl and a wooden spoon. We're talking about colossal mixers. Some can handle thousands of pounds of dough at once. Imagine a stainless steel bathtub, but for dough, with giant spiral arms or horizontal bars doing the kneading. These machines are powerful, designed for heavy-duty work. They combine ingredients thoroughly and develop gluten. The mixing process is incredibly precise. The order of ingredients matters. The mixing time matters. The speed of the mixer blades matters. Even the temperature of the dough is constantly monitored. Friction from mixing can heat things up too much. So, some mixers even have cooling jackets, using chilled water or glycol to maintain ideal dough temps. Proper mixing hydrates the flour completely. It distributes the yeast evenly for a consistent rise. And most importantly, it develops the gluten. Undermixed dough, weak, poor volume, crumbly texture. Overmixed dough, tough, bucky, hard to work with. The goal is a perfectly smooth, elastic, and pliable dough. Modern factories use sophisticated control systems. Operators input recipes into computers, which then control the ingredient weighing and mixing cycles. Sensors monitor everything: time, temperature, energy input. This ensures batch-to-batch consistency, a critical factor when you're making millions of loaves. The sound of these mixers is the factory's heartbeat, a rhythmic whirring and churning transforming simple elements into the very soul of bread, the dough. After mixing, the dough needs to rest and rise. This is called proofing or bulk fermentation. The dough is often transferred to large troughs or tubs. These containers can hold hundreds, even thousands of pounds. They are then moved to a special room, a proofing room, climate-controlled to perfection. Think warm, humid, like a tropical vacation for dough. usually around 80 to 90 degrees Fahrenheit with high humidity. What's happening during this first proof? The yeast gets to work, feasting on sugars in the flour. As it eats, it produces carbon dioxide gas. These gas bubbles get trapped by the gluten network, causing the dough to expand, to rise, to double in size. This process also develops flavor. Complex organic acids and esters are created, giving the bread its characteristic taste and aroma. The duration of this first proof is crucial. It can range from 1 to several hours, depending on the type of bread and the recipe. Factory bakers monitor the dough carefully. They look for visual cues, like the amount of rise. They might also perform a poke test, gently pressing the dough to see if it springs back slowly. This first rise is fundamental. It sets the stage for the bread's final texture and flavor. Section 5. Divide, round, conquer, crafting uniformity. Once the dough has completed its first proof, it's alive, puffy, gassy, and full of potential. The divider cuts the bulk dough into individual pieces, each precisely weighed. Rounding creates a smooth skin, trapping gas and giving uniform shape. The molder shapes the dough balls into their final loaf form. This process ensures uniformity and consistency in every loaf. Section 6. The final ascent, secrets of the second proof. The newly shaped loaves are not ready for the oven just yet. They need one more rise. This is the second proof, or final proof. The shaped dough pieces are placed into baking pans or onto baking sheets if they are hearth-style loaves. These pans then embark on a journey, usually on automated conveyor systems, into another climate-controlled chamber, the final proofer. This environment is similar to the first proofing room, warm and humid, to encourage the yeast to get busy again. This final proof is where the loaf achieves its ultimate volume. The yeast continues to produce carbon dioxide, inflating the dough within the confines of the pan or its own shape. This creates the light, airy texture we love in bread. The duration of this proof is critical. Typically it lasts about an hour, but it varies. Bakers watch for the dough to nearly double in size and to develop a soft, pillowy feel. Timing here is everything for the perfect crumb. Overproofing is a baker's nightmare at this stage. If the dough rises too much, the gluten structure can overstretch. It becomes weak, like an overinflated balloon. The loaf might collapse in the oven or have large, irregular holes and a sour taste. Underproofing is no good either, resulting in a dense, heavy loaf with poor volume. Modern final proofers are technological wonders. They can be vast, multi-level systems with conveyors gently moving thousands of pans through. Temperature, humidity, and airflow are minutely controlled, ensuring every single loaf proofs perfectly. Section 7. Trial by fire, baking by the thousand. The moment of truth has arrived, baking. Perfectly proofed loaves move steadily towards the ovens. And these aren't your home ovens, not by a long shot. We're talking colossal tunnel ovens or massive rack ovens. Tunnel ovens can be over 100 feet long. Loaves travel through them on a continuous conveyor belt. Imagine a slow-moving river of bread flowing through heat. These ovens bake thousands of loaves per hour. It's a continuous, highly efficient operation. Inside the oven, a series of amazing transformations occur. First, there's oven spring. The heat energizes the yeast for one last burst of activity, producing more carbon dioxide, causing the loaf to expand rapidly. The heat also causes gases within the dough to expand. Then, as temperatures rise further, the yeast dies off, enzymes are deactivated, and the starch gelatinizes. This means the starch granules absorb water and swell, setting the structure of the crumb, making it firm yet tender. The heat also works its magic on the crust through a process called the Maillard reaction. Sugars and amino acids on the surface interact, creating that beautiful golden brown color and the complex, delicious flavors and aromas of baked bread. Steam is often injected into the oven at the start of baking. This keeps the crust soft initially, allowing for maximum oven spring, and later contributes to a thinner, crispier crust. Temperature control within these giant ovens is incredibly precise. Different zones within a tunnel oven can have different temperatures and different humidity levels. This allows for optimal baking throughout the loaf's journey, from the initial burst of oven spring to the final crust development. Computers monitor and adjust these conditions constantly, ensuring every loaf is baked to perfection. The smell? Oh, the smell is heavenly. The entire factory is filled with the aroma of baking bread. Section 8. The Big Chill. Why cooling can't be rushed. Out of the fiery ovens they come, golden and glorious. But the journey isn't over yet, not by a long shot. The loaves are incredibly hot, around 200 degrees Fahrenheit internally. They need to cool down. And this isn't just a casual thing. Cooling is a critical step in the bread-making process. Attempting to slice or package hot bread is a disaster. It's too soft. It would compress and tear. The steam trapped inside also needs to escape. Proper cooling prevents a gummy crumb and a soggy crust, so the freshly baked loaves embark on another conveyor ride, this time to cooling towers or spiral coolers. These can be enormous structures, often several stories high, designed to maximize air circulation around each loaf. The bread travels slowly, up and down or in a spiral, allowing it to cool gradually and evenly. This process can take anywhere from 1 to 2 hours depending on the size and type of bread, and the ambient temperature and humidity of the cooling area. Rapid cooling can be detrimental. If cooled too quickly, the crust can crack. Moisture can be trapped inside, leading to a shorter shelf life, so the environment in these cooling areas is also controlled. Not as hot as a proofer, but not a freezer either. Gentle air movement helps to wick away heat and moisture. The goal is to bring the internal temperature of the loaves down to about 90 to 100 degrees Fahrenheit. This is the ideal temperature for slicing and packaging. During cooling, the bread's structure continues to set. Only when properly cooled is it ready for the slicer and its destiny on your plate. Section 9. Slice of life packaging and the journey to you. Once cooled to perfection, the loaves are ready for their close-up. And for most commercial bread, that means slicing. After slicing, it's straight to packaging. Automated machines deftly open plastic bags. The bag is sealed, usually with a plastic clip or a twist tie. Hundreds of loaves packaged per minute. Trucks are loaded, delivering fresh bread to stores, so that when you reach for a loaf, it's fresh.